What's up everyone? Today I want to discuss some mathematical formulas and mechanics you need to know if you want to play competitive Pokemon to a high level. So some of these might sound pretty daunting, so I'm going to do my best to explain them to you in pretty simple terms and break them down in the least mathematical way possible. So with that, let's jump right into them. Firstly, let's look at the Pokemon damage calculation. The formula is complicated to say the least. Thankfully, I'm not here to break down the entire formula. In fact, you actually don't need to know most of this, or it's actually pretty straightforward. Today, we are only interested in one particular number, and that's the random number. You might hear me or other Pokemon players refer to things as rolls or ranges, or discuss high and low rolls. This random number is what we're talking about. This random number produces one of 16 random values between 0.85 and 1 to 2 decimal places. What I mean by this is the value can be 0.85, 0.86, 0.87, all the way up to 1.00. This value is then multiplied by the damage you would do. Why this is important to know is, the chances of your attack doing the exact same damage turn after turn is actually only 1 in 16. Let's take for example, you do 50% damage to your opponent. Next time you use that same attack, you're actually not guaranteed to do 50%, as that 50% was only one of 16 potential values. Understanding if that attack was a high roll, a low roll, or a medium roll is generally very important to understand if it's a good idea to click that attack again. A high roll is generally a damage roll with a value closer or equal to 1, and a low roll being a value closer or equal to 0.85. Now, it's not expected of any player to understand what values every roll can be at all times. However, it is important to be aware that they exist. I've linked the damage calculator in the description below, which I would highly recommend to any players playing at a competitive level how to understand damage rolls better. Rounding is an important part of any equation in math using whole numbers. However, its application in Pokemon is super important to understand at a competitive level. In Pokemon, if for any reason there would be a decimal place, the decimal place is dropped, essentially meaning it's rounded down, but for any value that is not the next whole number. For example, if the value is 255.1 or 255.9, the end value will still always be 255. Where this is super important in competitive Pokemon is when we deal with anything that reduces HP by X% effects, the most notable ones being Stealth Rocks and Substitute. In the case of Substitute, it takes 25% of your HP to cast. With a whole number, for example, 100, it will take exactly 25 HP to cast, meaning after casting it 3 times, for a total of 75 HP, your Pokemon will only have 25 HP remaining, meaning the 4th cast will fail, as it would drop your Pokemon down to 0 HP. If your Pokemon has 101 HP, a cast of a substitute would cost 25.25 HP. However, since Pokemon completely ignores any decimal places, it still only costs 25 HP per cast, meaning after 3 casts, your Pokemon will have 26 HP remaining, meaning it can cast the final substitute and live on 1 HP. An even more severe example is entry hazards. Let's take Stealth Rock for example. On entry, Charizard takes 50% of its HP in Stealth Rock damage. This means, theoretically, if Charizard swaps into Stealth Rocks twice, it instantly faints. However, this can actually be prevented. If your Charizard has an uneven amount of HP, again let's take 101, every time it swaps in, it would take 50.5%. However, since the 0.5% is dropped, it only takes 50 points of damage, meaning when it swaps in twice, it will still have 1 HP remaining, which is very crucial in Pokemon, as you want to keep your Pokemon alive as long as possible. Until now, I've only discussed having uneven HP, which is generally preferred, however not always. When it's not preferred is in the case of Pokemon that want to hit a certain threshold of HP. Let's take for example a Belly Drummer. Belly Drum can be used to cut the user's HP in half, which can actually be quite useful for activating berries. Let's take Citrus Berry for an example. Citrus Berry activates at exactly 50% or lower HP, so after a Belly Drum we can force a Citrus Berry to activate immediately, with an even amount of HP. With 100 HP, after a Belly Drum we have 50, which is half of 100, which activates our Citrus Berry. If we have 101 HP however, it drops us down to 51 HP, therefore we are not under the 50% threshold, and our Citrus Berry will not activate. This is the case for other HP threshold berries. Ones that activate at 25%, for example, can be used after 3 substitute casts at an even HP to guarantee its activation. It's important when building a Pokemon to understand if you want an even or uneven HP stat, to understand what you want to activate. Next up, let's discuss base stat totals. This is something I see a lot of players not understand fully, and I can understand why. It's not too intuitive, so let's break it down. At level 100, without taking into account any variables such as EVs, IVs and nature, a base stat is calculated by the formula 2 multiplied by x plus 5, or in the case of HP, 2 multiplied by x plus 110, where x is the base stat. For example, let's look at Azumarill. Azumarill has a base HP of 100, so with no external investments, at level 100 its HP is 310, which we can see here from the formula. Let's look at another important stat, attack. Its base is 50, meaning with no external investment it will have 105 attack. The reason I took Azumarill as our example is because it has huge power. Huge power states that this Pokemon's attack is doubled. A common misconception by a lot of players is to think that the base stat is doubled. In this case, base 50 to base 100. In fact, it's a lot better than you think. It doubles its resulting attack, not its base. To prove this, let's look at a Pokemon with base 100 attack, Tangrowth. With no investment, its attack stat comes to 205, which is 5 less than that of a no investment Azumarill with huge power. But it becomes an even bigger boost after we take into account variables, such as IVs, EVs, natures, and items. Let's fully invest into Azumarill. It now has 218 attack, prior to huge power. Slap on huge power, and suddenly we have an attack stat of 436. The same max investment on a Tangrowth comes to only 328, proving how effective these stat boosts are. This also is the case for all choice items, stat boosting such as Swords Dance, Nasty Plot, etc., which goes to show how important they are in a competitive setting. Since we already discussed how base stats work, I think it's important to understand how stat changes work. To a lot of players, stat changes don't seem like a huge change, or might be a little confusing to how much they actually change your stats. Thankfully, there's a pretty easy formula that shows you exactly how the stats change. So let's have a look at the default setting. Usually, all your Pokemon's stats are set to a formula of 2 over 2. And every time you increase a stat or decrease a stat, the top or bottom number increases respectively. Let's look at an example. If we use Swords Dance, which increases your Pokemon's attack by 2 stages, we simply add 2 to the top number, making it 4 over 2, or 200% of the original value. Now let's say, for example, that same Pokemon landed on Sticky Webs, which decreases our speed by 1 stage. In this case, we just add 1 to the bottom number, making the formula 2 over 3, or roughly 67% of the original value. But let's clear up a distinction here in case anyone's confused. If your Pokemon is intimidated after a Swords Dance, it does not make the value 4 over 3, because a Pokemon still has plus 1 stage in attack, as is plus 2 minus 1, resulting in a value of 3 over 2. The maximum amount your stats can change is a deviation of 6 from the original value, so at max increase, you can see you have 8 over 2, or 400% of the original stat, and for max decrease, we have 2 over 8, or 25% of the original stat. Hopefully this formula clears up just how good stat changes actually are to a Pokemon. I said earlier, this is the case for all stats, but that's technically untrue. For some weird reason, accuracy and evasion uses its own base formula of 3 over 3, however, the increase and decrease formula is the exact same by adding 1 to the top or bottom respectively. Let's talk stat distribution. Distributing stats can often be a very daunting task for a lot of Pokemon. The typical 2-5-2, 2-5-2-4 spread is often suitable for a lot of Pokemon who want to maximize their effectiveness in one specific role. However, if you're looking for a very specific stat spread and looking to hit exact numbers, there are some things worth noting. Let's have a look at some stat optimization for 2 defensive Pokemon, Ferrothorn and Crobat. I would like to state that these stats aren't exactly ones you may choose to run, but they're very good examples of how important it is to distribute stats. Let's say we want a defensive Ferrothorn with exactly 336 HP, for exactly 1/16th leftover recovery, but we also want to have 350 defense, and the rest we want to pump into attack. There's actually 2 ways of achieving this. We can either invest 112 EVs with a positive nature into attack, and 208 EVs into defense, or we can invest 236 EVs into attack, and 84 and a positive nature into defense. It's reasonable to think that the first option is better. However, due to the way calculations work in Pokemon, it's actually not. The second option is technically better, as you get 6 extra points of attack, which sounds a little trivial, but it could be the difference between KOing a Pokemon and not KOing a Pokemon, which is a very important distinction in competitive. Let's take a look at a defensive Crobat. Here we want to maximize our HP to optimize roost healing and our general bulk, but we also need exactly 334 speed to outspeed Garchomp. Again, there are 2 different ways of achieving this. We can either go for 104 plus defense and 152 speed, or we can go for 224 defense and 32 plus speed. Again, in this situation, the second option is preferred, as we get 8 extra points of defense, while keeping our speed and HP the exact same. It's normal to assume you want a nature in the stat you invested most EVs into, however this is often not the case, so make sure you experiment with the Pokemon and try to find these small optimizations when team building. Let's take a look at another example of stat distribution. In this case, we're building a Blissey, and we're not sure if we want to invest in an already fantastic special defense, or do we want to invest in some defense. For the purpose of this calculation, we're not going to use any natures, just to show how powerful EVs alone can be. Let's run some quick calculations using Kyurem as the opponent, as both its physical and special attack are equal. We'll also be using Hyper Beam and Giga Impact respectively, as are the exact same move, but one's physical and one's special. We can see on screen the damage a Kyurem does with Hyper Beam to a Blissey with 0 special defense and max special defense. You can see with max special defense, it's the possibility of a 6-hit KO, with 0 special defense, it's the possibility of a 5-hit KO. The difference in damage, however, is actually only 3%, which is not massive. Now, let's run the exact same calculations but on the physical side. We can see here a Blissey with no defense investment and a Blissey with max defense investment taking a Giga Impact from Kyurem. With no defense investment, it has a 75% chance of 1-hit KOing your Blissey. However, with max defense investment, it's only a 37.9% to doing a 2-hit KO, which is a massive difference overall. The reason behind this is Pokemon calculates damage on a multiplication basis as opposed to an additive basis, making investing in a low stat often worthwhile for the purpose of tanking, as opposed to adding more to an already strong stat. Hopefully this video helped break down some of the complex maths behind Pokemon. If you have any more questions, feel free to ask in the comments. I'm more than happy to answer them. And with that, thank you so much for watching. I hope you have a great day, take care everyone, and I'll catch you next time.